Rainy Day Productions has found that the fraction of the population in a market that buys tickets to their monster truck shows can be accurately approximated by 1 minus 0.01p, where p is price as long as price is below $100 per ticket. They are considering putting on a show in a market with a population of 100,000 people in a stadium that can seat up to 10,000 people with a constant variable cost per ticket purchased of $20. The first question says, what is the profit function for the show if it is not sold out? So we're ignoring the capacity constraints here. Well, we know that profit is equal to total revenue minus total cost, which can also be written like this: price minus marginal cost times quantity. We know that quantity is equal to n, the number of people in the population, times the fraction of the population that will actually purchase a ticket. So we can rewrite our profit function like this. Now, to get it into a form that we see it on a multiple choice test, oftentimes we're going to have to algebraically manipulate it a little bit. So we do so, and we just reorganize things and put the 100,000 in front times the 1 minus 0.01p, and then the price minus marginal cost at the end, just so it matches one of the answer choices given to us. We haven't changed anything, of course, it's the same thing. The second question says, what quantity of tickets is sold to maximize profits in this case? Well, we know that profit we just found. We can rewrite profit like this after we've distributed through the 100,000 into the 1 minus 0.01p. Now we're ready to take the derivative of this profit function with respect to p. So we're going to use the product rule, which says first times the derivative of second plus second times the derivative of first. Well, here, first times the derivative of the second, which is p minus 20, is just 1, plus second times the derivative of first. The derivative of the first thing, which is 100,000 minus 1,000p, is just negative 1,000. So we're ready to set this equal to 0, do some algebra and combine like terms, and solve. We can add 2,000p to each side and divide through by 2,000, and we find that the optimal price we should be charging is $60. So let's see what quantity we would sell at a price of 60, because it said what quantity of tickets is sold to maximize profit. So we're looking for quantity. Well, when we plug in 60 here and we do the math, we find that the optimal quantity we'd sell is 40,000 units. Well, if you remember in the beginning, our capacity constraint was 10,000 seats. So we know we're going to have a sold out show. So in this case, we're not trying to find optimal price. They only asked about quantity. And since we found that the quantity would be 40,000, but the venue can only hold 1,000, we know that our quantity in this case is 10,000 seats.